Summation notation is when you have this kind of fancy looking E. It is the Greek letter for capital sigma. And we'll do a couple different examples and then we'll go back and talk about the definition. So when you do an example of a summation notation problem, what you'll be given is an E with a number on the bottom, I equals 1, a number on the top, 5, and then a formula. And what you'll do is take the number on the bottom and plug it in the formula. So we'll plug in 1 for I. Then we add and we go up a number, so now we'll plug in 2. Then we plug in 3. Then we just keep plugging in numbers. And what you'll do is continue to plug in numbers until you've plugged in the top number. So you plug in the bottom number, up, 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 until you've plugged in the top number, then you stop and you add up all those numbers. When you add 3 plus 6 plus 9 plus 12 plus 15, you get 45. So your answer is the sum of those numbers. For the next one, the bottom number is 3. So I'm going to plug in 3 and then plug in 4. I have to rewrite that whole formula every time, plugging in the number. Then plug in 5, then plug in 6. I've plugged in 3, I went up, plugged in 4, 5. When I plug in 6, then I'm done. So here I get 1 plus 9 plus 1 plus 16 plus 1 plus 25 plus 1 plus 36. And for this one, the answer would be 90. The last one, I would start by plugging in 0. And then I plug in 1, 2, plug in all the numbers till you've plugged in 8. And with that one, I got 204. So that's how you would do a problem. The definition, we will say I equals some number A, and the number on top could be some number B, and then here you'll have, I was going to write formula, but we'll write f of x. You have some kind of function. And what you want to do is first plug in A, then plug in A plus 1, then plug in A plus 2, and just keep doing that until you've plugged in B. Then stop, add those up, and you'll be done. The next topic of this section is recursive versus explicit formulas. When we work with sequences, these are the two different types of formulas that we'll see. Here's an example of an explicit formula. Here's an example of a recursive formula. With an explicit formula, you can find the fourth term by plugging in 4. So the fourth term would be A sub 4, and then we would just plug in 4 for n. So to get the fourth term for an explicit formula, you plug in 4. Here we get 16 times 2 is 32 plus 1. So the fourth term is 33. So explicit formulas just have an n in them. Explicit formulas, you can jump to nth term, which means whatever term you want, you can just get it. If you want the 100th term, you can just have it. Plug in 100. A recursive formula is different. A recursive formula has two parts. The first part is the first term, and the second part is the formula. So here they start us off with 5. And then there's a formula on how to find the next term. So if I want the fourth term, I actually need the third term in order to get that. If I want the third term, I need the second term to get that. If I want the second term, I need the first. So with the recursive formula, if you're asked for the 100th term, you would need all 99 terms in front of it in order to get it. So it's more of a build on the previous term than a jump right to it. So uses previous term. So here this says A sub n plus 1. That means to find the next term equals to use the previous term. A sub n means previous term plus 1. So to find the fourth term, if we have the first, I have to find the second term next. So this says to find the second term, you would take 2 times the previous term. What's the previous term? 5 plus 1. And the second term's 11. Now we'll find the third term. So we take 2 times the previous term. What's the previous term? The second term's 11 plus 1, so we get 23. Now we can actually go for the fourth term, which is what we want. And we use the same formula. 2 times the previous term is 23 plus 1. So in order to use a recursive formula, you need all the terms before it to get there. So I thought what we would do is show you the difference with the same sequence, but show you an explicit example and a recursive example. So if this is your formula, 2, 4, 6, or your sequence, 2, 4, 6, 8, we want to write a recursive formula for that. So it'll look like this. It will have an n in it, and then we'll write a recursive formula. It will look like this with the 2 parts. So explicit, what I like to do for explicit is write the number of term right on top. So the first term is 2, the second term is 4, the third term is 6, and the fourth term is 8. So to find the nth term, what does it look like the pattern is? Like if I wanted to find the 5th term, how would I find it? Well, it looks like whatever term number it is, you double that term number to get the number. So if I wanted the 5th term, take 5, double it, I'd get 10. To find the 6th term, I double it and get 12. So my explicit formula is 2n. Explicit formulas just have n's in them. Now a recursive formula has 2 parts. The first part is defining the first term. The second part is writing the rule, and the rule is how do you get the next term from the previous term, and the rule here is plus 2. So what I'll do is write a sub n, which represents the previous term, and then write plus 2, because you always take the previous term and add 2. So it looks previous instead of up above to get that term. I do want to point out one more thing before we stop here. Sometimes you'll see recursive formulas looking like this. These two are exactly the same. This one says a sub n plus 1 and a sub n. This one said a sub n and a sub n minus 1. These are the same. It's just this one says looking to the next term, take the nth term, which is previous, and find it. This one says to find the nth term, look at the one previous. So you'll see it written either way and it means the same thing.